Hello, my name is Heiko Seitz, technical author here at IDS, and I welcome you to our technology interview, which is about the trendy topic of smart farming. In particular, we are talking about the controversial use of crop protection products and their positive and negative effects on agriculture. And of course, how modern machines with camera technology can help in this area. Because when we buy vegetables or crops today, we are aware that pest control products are an essential part of today's agriculture. They have to protect the crops and keep weeds and parasites under control. Unfortunately, these crops protection products also cause numerous risks for humans and the environment. For example, they can affect biodiversity or the water quality of neighboring areas. So a team of students from the Technical University of Zurich has faced this challenge and developed a robot for more sustainable agriculture without excessive use of such chemicals. Here at IDS, the topic of sustainability is also present in our daily work. Therefore, we are, of course, very proud that our IDS cameras are being used in this sustainable product development. Reason enough for us to take a closer look. My interview guest today is Timo Schöneck, a student of the Technical University of Zurich, who can tell us more about the autonomous weed control robot, Rosie. Hello, Timo. Nice to have you here with us today.
Thank you, Heiko.
Hi. Timo, could you please start by saying a few words about yourself and your team?
Sure. So my name is Timo Schöneck, and I'm currently doing my master at robotics at ETH Zurich. So my bachelor, I studied electrical engineering, and during the last year of my bachelor, I had the exciting opportunity to develop an agricultural robot in a team of 10 students. So we were 6 mechanical engineers, 2 electrical engineers, and 2 industrial designers. And after finishing the hardware development, we shifted the focus on software. And currently, we are 3 students driving the project forward.
Okay, thank you very much. So now we have an overview of the expertise of you and your team. Can you tell us more about the mentioned project on which you are working together?
Sure. So ETH offers engineering students in the final bachelor year the possibility to gain hands-on experience. Those projects are called focus projects, and students have the task to develop a new product from scratch. There's a large variety of focus projects, like, for example, developing an electric aircraft or to build a drone that can catch other drones. And our task was to create a robot to make agriculture more sustainable. In only 9 months, we then developed our first prototype, the autonomous weeding robot, Rosie. And because it worked very good, we decided to continue with the project. And now we are already developing the robot since 3 years.
We are pleased to hear that the development of your weed control robot called Rosie has been so successful. What is the goal of Rosie?
Agriculture is a very labor-intense work, and there's not much automated yet. Robots have a huge potential to change this, as they can monitor the field and can provide the farmer with detailed information about the fields. Robots can help to reduce the usage of pesticides, as they can apply them only at those spots where they are actually needed, or even use completely mechanical solutions.
Okay, reducing the use of chemicals is, of course, a very desirable goal for both the plant operators and for us, the consumers. But what is the motivation behind this project for you and your colleagues?
One big problem in agriculture is the overuse of pesticides in the field. For example, herbicides are used to combat weeds. For some plants, they have to be applied every 2 weeks, which is quite a lot. And also fungicides are often used if there are any plant diseases. And detecting such diseases in an early stage is very challenging for the farmer, as all plants would need to be checked. Therefore, fungicides are also often used even if no plant diseases are detected, just to be on the safe side. You can imagine that the amount of chemicals sprayed on the field is quite large. Those toxic chemicals are also very harmful for insects, and they can pollute groundwater. Therefore, organic farming becomes more and more important. But nowadays, this is a very tedious manual labor work. For example, for weeding, people have to walk through the whole field, removing all the weeds manually. And we believe that autonomous robots can contribute to solving this problem.
Okay, why did you decide on the current robot setup? In other words, the use of camera.
In my opinion, cameras are the most crucial sensor for autonomous robots in general. Cameras are like the eyes of the farmer, but they can see much more using machine learning techniques. So RGB and near-infrared cameras can be used for plant monitoring, and stereo cameras are important for obstacle detection. But of course, there are many other applications for cameras. So cameras are very important, but on the other hand, the agricultural environment is very challenging for cameras due to mud, challenging lighting conditions, or vibrations on a robot. In order that the robot works also under those conditions very reliably, cameras must be very precise and also of high quality.
I mentioned at the beginning that IDS is happy when our cameras are used in sustainable projects. Why did you especially decide on our IDS cameras?
Yes, so we had quite a lot of requirements for the camera. So on the one hand side, it has to be IP65 to be dust and water protected because we are in agricultural environment. Then it also has to be compatible with the robot operating system ROS, which we use on our robot, so that we have a plug-and-play software integration and don't have to develop our own custom drivers, which takes usually quite a lot of time. We also need a short exposure time so that the camera provides us sharp images because we are filming the plants while the robot is moving through the field, so everything is quite shaky. And last but not least, we need a large field of view for the camera because the camera is mounted underneath the robot for the plant detection, so it is very close to the plants. Those are our main requirements, and luckily we found an IDS camera that fulfills all those requirements.
Okay. Can you explain what's the main task of the camera?
The main task of the IDS camera is crop monitoring. The camera is mounted underneath the robot, and it looks down at the plants. We've implemented a neural network that can distinguish between crops and weeds. We can also create a 3D model of each plant using the camera images. In the future, this information can be put into a map to provide the farmer with detailed information about the field. Such data is extremely valuable for the farmer, as it can give information about which plants need more fertilizer and also to detect plant diseases in an early stage. All this information can then be used to significantly reduce the use of chemicals in the field, and therefore to make farming much more sustainable.
So now that we have heard so much positives about Rosie, I would like to know, and I'm sure our viewers would too, when this helpful robot will be available for purchase. Can you give us an outlook? What are the next steps and why do you do that?
So one crucial point for autonomous agricultural vehicles is field navigation. Therefore, we have focused in the past months on developing a very robust navigation pipeline that is also doing challenging field conditions very reliable. We decided to focus on the navigation as, from our experience, this is the part where most problems occur due to unforeseen events. For navigation, obstacle detection is especially important. Therefore, we use 3D cameras and have developed obstacle detection algorithms. So you ask when Rosie will be available for purchase. The step from nowadays agriculture to autonomous field robots is huge. Having many Rosies in the field is therefore still a long way to go. Therefore, we have decided that we will make an intermediate step and will first make tractors autonomous. We are now planning to bring Rosie's navigation technology to existing tractors. Autonomous tractors have huge benefits for farmers. Farmers can still drive the tractor through the field, but in the field itself, the tractor runs completely autonomously and the farmer can focus on other important things. Autonomous tractors can then be equipped with smart implements like mechanical reading tools. We have now successfully tested our navigation software on Rosie and are currently looking for interested tractor manufacturers or farmers who can lend us their tractor, where we can implement then our technology. We are very confident that at one point we can bring a product to the market that is a reliable for farmers and that helps to make agriculture more efficient and sustainable.
That sounds very promising. Is there anything you want to add that we haven't mentioned yet?
From the technical side, I think we have spoken about everything. So I want to use this opportunity to say a big thank you to IDS for your great support and flexibility, also in the name of the whole team. Such projects heavily rely on the support from industry, and we are very happy to have you on board. And of course, we are also very happy with the quality of the camera. It completely fulfills our requirements. So again, thanks a lot for your great support.
We have to say thank you. Projects like Your Autonomous Robot shows us how differently and successfully our cameras are used. And of course, this also gives us good insights into where we can still improve. So thank you very much, Timo, for your time. The interview was very interesting, and I'm sure that it would be a big step towards more sustainability agriculture if many roses were used in agriculture in the future. With this in mind, we wish you and the whole team all the best for the future.
Thank you, Heiko, for the nice interview.